Welcome everyone to the third Sound Studies Institute lecture of the 2021-22 academic year. We're coming to you from Amisquatchie, Muskegon, sometimes known as Edmonton, Alberta. We're in Treaty 6 territory here, which is the traditional homeland of the Cree, Blackfoot, Métis, Nakota Sioux, Iroquois, D.M.A, Ojibwe, Inuit, and many other indigenous people. We like to say sound and music have been heard, created, and celebrated here for thousands of years by many diverse First Nations and cultures. And tonight we want to humbly add our sounds to this history with respect and solidarity. If you're here for the first time, welcome. Sound Studies Institute is a research institute at the University of Alberta that celebrates and supports research into sound from all angles, including performative and artistic understandings of sound, of course, including music, but also other human and non-human understandings of sound and the role it plays in our world. And as I said at the top, this is the third lecture of this SSI series, but it's also a special kickoff talk for a symposium on research creation that's going to be happening over the next couple days. And I just want to tell you a little bit about that before we begin tonight. So some of you may have heard of the term research creation, or perhaps if you've heard terms like arts-based research or practice-based research and other terms that are trying to articulate a relationship between creative practices and what we traditionally refer to as research in an academic context. So over the years, creative practices are becoming more and more seriously considered as valid modalities for research, both in terms of process and also just presentation, of course, presenting research as creative work. And this is to the point where, for example, a graduate student thesis or dissertation might just as well be a play or a musical performance as it might be a written text, for example. So in 2019, I think it was 2019, maybe it was a year before, I'm getting it, but we, the University of Alberta's Faculty of Arts recognized research creation as a signature area and supported us in the formation of SPARK, which is an acronym that stands for Shifting Praxis in Artistic Research and Research Creation. SPARK is led by a 5-member leadership team from the fine arts faculty here at the university, including myself from music, Bo Coleman from drama, Jillian Harvey, Sean Caulfield, and Natalie Lovelace from art and design as well. And I think they're all here tonight. If you want to show your camera real quick and wave to everybody, that'd be great. Our goal through SPARK is highlighting work being done in research creation at the University of Alberta, as well as across Canada and really even internationally. And this symposium is an attempt to take the temperature of the room, so to speak, in terms of kind of looking at the current state of the field of research creation, particularly in these urgent times that we're living in. So we're really excited to be presenting this symposium over the next 3 days, really, including tonight. There will be several panels, some artwork to look at, sounds to listen to, performances to watch, all kinds of great events. The symposium events are all free, and you can find a full schedule of those events on the SPARK website, which I will put into the chat in just a few minutes when the talk starts. And so if you'd like to check out some of the other events that are happening in the symposium, tomorrow and Friday, please join us. We look forward to seeing you there. Again, all events are free. And so our guest this evening is a research creationist. Courtney Brown is a composer and performer, software developer, and tango dancer. I first met Courtney in, I think it was 2014, maybe it was 2015. I forget the exact year, but it was at the New Instruments for Musical Expression conference in Baton Rouge, I think is where that was. And I saw her give this paper that I was blown away by. And we were able to exhibit one of her skulls at an exhibition here, I think a year later. She creates new musical interfaces, which act as a kind of a way to create sound that's transformed. She's interested in transforming sounds But in this particular kind of instruments, people become dinosaurs by blowing into a hadrosaur skull and creating their own roar. And so this is really interesting work. Courtney is using scientific processes and collaborating with people across the sciences to try to recreate or at least to create a situation where one might speculate about what it would sound, what an actual hadrosaur in particular skull might sound like, what a roar might sound like. And so she's been working on this work for a few years. Her work in general has been featured and performed all over North America and Europe and Asia, including Ars Electronica, NPR, National Public Radio, the Diapason Gallery, which is one of the first sound art galleries in the US, and lots of other places. She received her D.M.A. in digital media and performance from Arizona State University and her M.A. in electroacoustic music from Dartmouth College. She's currently an assistant professor at the Center for Creative Computation at Southern Methodist University. And I don't think that this is really a proper Lambeosaurine hadrosaur. I'm probably pronouncing it wrong, but it looks kind of something like this. And so Courtney is going to tell us all about these dinosaurs and what they might have sounded like and how her work as an artist has been inspired by the possibilities of these sounds. So I'm just really excited to have her here, and I'll turn it over to Courtney.
All right, thank you so much, Scott. That was a great introduction. I can't ask for a better one. So we're here to talk about becoming a hadrosaur. So first I wanted to show you what maybe becoming hadrosaur sounds like. So I'm blowing into a mouthpiece, which excites a mechanical larynx, which I created. And then the sound from that larynx is resonated through the nasal passages and the crest of this Corythosaurus, which is a Lambeosaurine hadrosaur. And so these are duck-billed dinosaurs. And as you can see, they do have these hollow head crests. This one is a subadult, and so it does not have as large a head crest as, say, the adult pictured behind me, which was found in Alberta in the Red Deer River Valley. So why did I do this? To create a musical instrument from a dinosaur skull. So I was traveling across country and I stopped by a New Mexican museum in Tucumcari, and I heard this. So I'm gonna go on. So this is the sound of a Parasaurolophilus, which is also a Lambeosaurine hadrosaur. I believe it's the same hadrosaur that Scott showed you, the toy version. And then this is a simulated call created by Sandia Labs. And I pressed a button and I heard this sound. And I am a singer. I've identified as a singer since my memory begins. So that's quite a long time. And so when I heard this dinosaur, I realized that maybe this dinosaur was also a singer. And all of a sudden, I loved this dinosaur. I loved this dinosaur so much because I identified with this dinosaur as part of myself. And I became interested also in how I interacted with this dinosaur, which was, as I said, I pressed a button. So my research has long been in interactive music and in building instruments. And so when I pressed the button, I thought, there's definitely a better way. This is not how I want to experience the sound, because I want the sound to be intimate and expressive, like, say, the accordion that I play. Or you can see, so here's Michael Weisfitch. He's one of the first people to create new musical instrument. Those are his hands, instrument that he's playing there. Or, you know, a DJ, even, you can turn knobs. People find the sliders expressive, or, you know, violin. And one thing is that if you're a musician, that you know that when you play, the instrument starts to feel like it's a part of you. It's not separate. You are your instruments. And so I want to be a bit precise in what I mean is that I don't press the keys down on the accordion and then the accordion plays the sound. Physically, that's what's happening, but my lived experience is I make sound. There's not a separation. So the incorporation of musical instruments into the self, and in fact, there is preliminary research to suggest that this is not just a metaphor. This describes an experience that we have rooted in our unconscious, in the sense, in this part of the sensory motor system that defines self versus non-self. So it's not that like, well, my accordion is in a case in the other room that I think that is now a part of me. But while I'm playing it, it momentarily becomes part of my experience. And if we bring it back to the dinosaur, I became really interested, and I am very interested, what it means to become part of a dinosaur skull. This lived experience, the accumulation of experience, just like a musical instrument. But we can also take it into the momentary experience. So like I initially conceived it as a gallery offering. Even then we have like an embodied experience where, and several participants have said that they knew dinosaurs were big and they could see that they were big. But then when you have to produce the kind of air to produce the sound, like for instance, a lot of air to blow into a tuba, so they can't start little kids on full tubas because they do not have the lungs. But when you when you create this Hadrosaur Sounds, many people do not have the lungs. They can like muster up the air, but they realize, dinosaurs are big, and now I feel it inside my body. And so as I've been doing this project, I'm interested, and I want to highlight music as research. So first thing is an archaeological, from archaeology. And so that is a so-called Neanderthal flute. It was found, so a piece of bone with holes in it that were found near Neanderthal remains. So we think it might be a flute. And so one of the ways that they found out, they did research on this, is to create a replica, and they have musicians play it, and they could make music, which I found incredibly fascinating. Especially at the time that they were testing it, the general consensus is that Neanderthals may not have the kind of symbolic thought or reasoning processes to create music or create instruments. So it was quite controversial. And what they did find is they could make music on it. Now, does that mean that the flute is a flute? Or it's a flute now, but was it a flute for Neanderthals? Did they play on it? And we can't know that, but we can say with the work of these musicians that the possibility isn't closed. It's open. Another researcher that I want to highlight is David Dunn, who I think is a big pioneer in music as research and acoustic ecology in general. And And so his work on pinyon bark beetles. And these are beetles that have been infesting the pinyon trees across the western part of the US and have been just decimating forests. It is tragic. And he's been doing this. And so for decades, he has been exploring this problem and finding new ways of recording the audio of these creatures and discovering different ways that they have used sound to communicate with each other, acoustic signaling. And then he has created musical pieces which highlight their sounds and thus the problem. So this is an excerpt from his work, The Sound of Light and Trees. It's really fascinating. The other thing is that has come out of it is that he's found ways of killing them via sound or controlling them because of their acoustic signaling. Determines or modifies many of their behaviors. So, for instance, there are sounds that can make them turn against each other and eat each other. So therefore they can actually start to have like an interesting, non-invasive way of saving these trees, which I think is amazing. And then lastly on this slide, I just want to touch on the work of David Rothenberg, who improvises with different animals. And then attempts to have a back and forth so that they're playing music together, which I love. And so he's done this with cicadas, and here's just an excerpt of him with whales. And then they sometimes seem to respond, but I think what's kind of fascinating is, are they, and what does it mean to the animal, like trying to get inside, trying to create an interspecies bond.
We're going out to meet the whales and make some music with them. Come on.
And what I will say is that this is what I wish I could do with Corythosauruses, so I'm very jealous of this man. All right. All right, so I've been looking at, so it's illustrative to look at dinosaurs in popular media and how those sounds are constructed as well. So as you can see, Jurassic Park is kind of the seminal work for this. And in fact, I'm told that many people go into various dinosaur fields in paleontology because of this movie. So let's just watch this brief excerpt.
Nobody move a muscle.
So the first thing I noticed that the Tyrannosaurus, of course, has feathers. But secondly, it's really fascinating how they created these sounds. So these are like a big mashup of existing sounds. I know that they have used for various dinosaurs the sounds of mating turtles, screaming monkeys, and they have used a distant dinosaur relative, the crocodile. And I think there's like, I think there's a tension between scientific rigor, which I do believe that the Jurassic Park movies, they consult with paleontologists, but there's also the tension between drama and the consistency between the movies and what the public finds fascinating about dinosaurs. And then lastly, for my context, I just wanted to talk about other works that bring voices to life. The first is a shout out to Perry Cook, this is his vocal work Spasm, which allows real-time synthesis of the human singing voice, which also allows you to have a real-time control and thus a evocative musical instrument, where you can control a voice using maybe your hands or something else, because you have control of these things in real time, as opposed to, say, the button, right, where you press a button and then the recorded sound comes out, which is quite a bit less expressive. And then secondly is this, The Opera of Prehistoric Creatures by Marguerite Mo. And so this also brings to life a larynx, larynges of extinct creatures. So she focuses on extinct mammals. And rather than discovering the past, she's looking into the future, the resuscitation of these animals. You can see in the futuristic design, for instance, and the air, and the pressurized air that causes the sounds. And in fact, she was exploring bringing, in a sense, say a woolly mammoth to life. And in fact, there are researchers trying to bring the woolly mammoth to life. They want to cross it with an Asian elephant, and then release them in the wild in order to somehow ameliorate climate change. And then it does make you think about unintended consequences, which, and then what kind of control should we have over these kind of creatures? And then here you see that just last year in 2020, they did bring to life the sound of an extinct mummy. So this is an Egyptian priest, and you can see they're also using CT scan technology. So as we'll discuss, later, larynges do not always preserve that well. They disintegrate, but especially when left to chance and nature. But Egyptians are very good at preserving things. And so that means that his larynx was also preserved, as well as you can see his face as well. It's crazy. And then you see they're using that same CT scan technology. So, and then finally, I wanted to address Paleo Art, because that's been a really important part in which the public has known dinosaurs, and which I consider, in some sense, my work to be part of Paleo Art, bringing public awareness to a conceptualization of dinosaurs. And the All Yesterdays movement in particular is interesting because they aim to be as scientifically rigorous as possible, but also as creative as possible, and to not reuse popular conceptions in the media over and over, but maybe inspiration from animals that might have convergent evolution or similar behaviors. So this is one of my favorite ones by John Conway. He wrote the book. He's the lead author on the book, All Yesterdays, and it's a bunch of Proceratops. They're related to Triceratops, and they are in trees. And so the model for this is in fact goats. Now, there's nothing in the fossil record to suggest that that Proceratops or Triceratops were like hanging out in trees, but there's nothing to suggest that they were not. And goats hang out in trees, which I did not realize until I saw this piece of artwork, which is partly why I love it, because then I had to go and YouTube a lot of goats and trees, because it's amazing to watch them go up trees. And then also I wanted to include Mark Whitten, who's also a paleontologist, because I love his pterosaurs. This is the Quetzalcoatl. Pterosaurs, so a pterodactyl is a pterosaur, for instance. They're related to dinosaurs, but they aren't dinosaurs. And then we're getting into the paleontology of dinosaur vocalization, which is really this, I'll tell you a lot of things that we don't know. So the first thing we don't know is soft tissue structures. So, and the larynx is mostly made of soft tissue. As you can see, as you look down the throat of this crocodile, who I assume is trying to eat you. Unfortunately, they decay, so we just don't know. But additionally, there has been the suggestion that, in fact, dinosaurs did not have voices. So a paleontologist did do an analysis and note that of the living archosaurs, that is, they are animals related to dinosaurs, birds and reptiles, crocodiles. They all have recently evolved their larynges and syringes and vocal mechanisms. And so it does not seem that any vocal mechanism carried over from the dinosaurs. Thus, he concludes that acoustic displays were done in other ways, perhaps percussively, similarly perhaps to like insects, which also do not have voices but make a lot of sound. However, there are other things, there's new and other thoughts in that area. And one of them is, has to do with an amazing find that was published in 2016. And that was that they found a syrinx, which is the bird vocal mechanism that was from the late Cretaceous. And it was amazing that the cartilage structures preserved. And so one of the things they note is that since these cartilage structures preserve, then like it is likely that the predecessors of birds did not have a syrinx or these cartilage structures. So other theropod dinosaurs, birds are theropod dinosaurs, velociraptors, Tyrannosaurus rex, it implies that Tyrannosaurus rex does not have a syrinx. Does that mean that the Tyrannosaurus rex did not have a voice? Well, luckily for my research, it does not imply that necessarily. But in fact, so this same researcher teamed up with a few others, and they looked at what kind of voices were dinosaurs likely to have. And they also note, in response to those who say that dinosaurs probably didn't have a voice, is that archosaurs, in fact, in terms of just closed mouth vocalizations, which they're exploring, they have innovated those 16 separate times at least, just closed mouth ones. So what's a closed mouth vocalization? It's just when your mouth is closed. And then open mouth is like when I'm talking. And you can see there's kind of these interesting sacs and so forth, which are also associated with these closed mouth mechanisms. And they intuit, or they have that the dinosaurs that use closed mouth because it's so prevalent in larger archosaurs, crocodiles, and birds. So the larger the animal, the more likely that they're going to be using a closed mouth vocalism, voice mechanism. And I do think it's interesting they show an ostrich, which is related to the Tyrannosaurus rex. And so now we can move on into hadrosaurs, which are the duck-billed dinosaurs with these huge head crests. So although we've been talking about birds, I just want to note that hadrosaurs and birds are actually not that close. So here's where birds are, and then here's where the duck-billed dinosaurs are. And then we think, oh, crocodiles are closer than birds, but crocodiles are actually not that close either. There's no really close living relative of a hadrosaur. So that's just how it is. And so then we get to talk about the first hadrosaur skull musical instrument, which was created by a paleontologist who was researching these Parasaurolopholuses. And that's the same dinosaur that I encountered in New Mexico. And he created a series of tubes that he blew into just to explore like what kind of sound resonation. Did it make the sound louder? For instance, it was the idea that these hollow skulls were and nasal passages were they really for sound resonation? And just like with the flute, he found this is an open possibility. But then they took it a bit further because we could start to do CT scans and see inside these skulls. And luckily, this is just a few years before I encountered my first dinosaur call. But so they explored different hypotheses here in terms, and then looking inside the head. So first hypotheses, which they did not necessarily need to do any CT scans for, but was that you could use these hollow crested skulls to hold air, because they initially thought, or some people thought that hadrosaurs were in fact semi-aquatic or aquatic creatures, partly because they were so large and they assumed they had webbed feet. However, that thinking, we do not think they are semi-aquatic or aquatic. And so therefore the idea that the skulls are actually holding air for them to breathe lost traction. And then a second hypothesis is that perhaps these hadrosaurs are super smellers. They need to get like all this air so they can like learn all about the environment through their smell. However, when they did this analysis, and here you can see it's pointing to the olfactory part of the brain, the smelling part of the brain. It was actually relatively small. So it was like unlikely that they were processing a ton of smell or olfactory information. However, the other thing they looked at was the inner ear, the cochlea. So the cochlea of archosaurs can tell you a few things. It can tell you the center range of your hearing, where you hear the best, and then the limit of the hearing. And they found that where each hadrosaur heard the best was right about where the resonating frequency was of their skull. And that was strong. That was pretty relatively strong support for the skull resonation, sound resonation hypothesis for these hollow crests, because the ears of vocalizing creatures, they are tuned to their own voices or our own voices. So our ears are tuned to our voices, particularly babies' voices. The babies cry, that piercing sound. Yeah. And so although we have found some things out about dinosaur vocalization, in fact, there is a lot that we do not know, and perhaps we cannot ever know, which can be extremely depressing. But we can also think, since I am a musician and I'm an artist, it can also be an opportunity. And so now I'm going to talk specifically about my work creating Rawr, a study in sonic skulls, in which I did use some of these opportunities. So again, this is a Corythosaurus. They are from Alberta. There's a few specimens that have been found in Montana, but they have mainly been found in the Alberta region. And they are herbivores, and they eat plants, and they have these large hollow crests that we love. So when I'm creating, so first I'll talk about the larynx and some design considerations. So first I was looking to existing animals and animal calls for inspiration. So for instance, crocodiles, and you'll hear this. The sound is a juvenile distress call, and it is, I believe, closed mouthed. So you can hear that it's quite a closed mouth sound, and you can also hear kind of like the what, let's say, Trevor Wishart, a sound artist and composer, would call the dynamic morphology. And so that means lots of frequencies and timbre and pitch and the amplitude envelope, they're all changing at once. It's not static, right? It's always changing throughout time. And so that's one of the features, as well as having like these complex spectrum of frequencies in the sounds. So, and by complex spectrum, we can also think of it as being a little more noisy. So I can make that as a sound. That's a noisy sound. And then for the specific skull, the CTs that I got, I do have the center frequency and the limit. So the first one, so that's the limit. So that's actually quite loud for us because it is kind of in that baby's call sound, but that is like where their hearing dropped off. So for comparison, what they say the normal frequency limit of human hearing is 20,000 hertz. So this is like an order difference. And then the center frequency here, that's 267 hertz. So quite a bit lower than my voice. And maybe there are some men that talk around that frequency. But so when I created a larynx, though, I needed to at least hit that center frequency and then below, because it's likely that they had these lower calls as well. And secondly, this is a musical instrument. So there was like quite a lot of concern about how to make it evocative, and so that musicians and participants could change parameters in real time so that we could have something that was expressive. That was like quite a large concern, as well as some practical considerations, such as like if it is a gallery exhibit, which it was, how do you create a physical interface that people can use that won't destroy the skull, that is somewhat of a natural interaction. So like when we so we can think of like what feels natural to us. So when we pull something tight, for instance, we expect it to go higher. And then if we let something get looser, we expect it to be lower. And this is reflected in our vocal cords, for instance. So here's some early larynx iterations. So I settled early on balloon as a pre-made material because I was really interested in creating something that was like at least somewhat close to like how a vocal mechanism would work in real life. And balloons are just like the closest material that you don't have to make like agar mix. That would be like vocal cords. And then here, the second one is a balloon, kind of inspired by a balloon bassoon. And it did have great low sound, but the interaction potential was extremely limited. You could only create so many frequencies. So you could press into this balloon that was on top of like a PVC pipe. But you can only press so far. So there was only so much. And then the timbre was basically the same. It was hard to change the timbre. So that was not mimicking a real voice. So what I came up with is to start using a skinny balloon. There was an experimental saxophone player who used to use that as an extended technique. And my advisor at the time, Garth Payne, pointed me, and then we were off. So all these are higher sounds, but it does go low, as you heard before. So it acts kind of as like a vibrating membrane, and it acts as a string. It's kind of like an in-between thing. You can also change timbres a little. I don't know if I have specifically, but you can fold the balloons over and they will make a different sound. So when you pull it, there's more tension, it gets higher. Rotating mouthpiece a lot. Well, I'm trying to get this one. Okay. So notice that there's two balloons. So there's in fact two sounds. So this was inspired by birds because some birds are polyphonic. And I was extremely fascinated by that. And you can create a lot more different timbres with two sound sources than one. So part of that is definitely part of the sound. You can get kind of a chorusing effect if they're close together in pitch, like around 5 to 10 hertz or something like that. Then they have it has kind of a chorusing, wavering tremolo effect. So it just allows more variation. In this case, I think that it's similar to the All Yesterdays movement where, well, there's nothing to suggest that hadrosaurs had polyphonic voices, but there's nothing to suggest that they necessarily didn't, and it'd be really cool if they did. So that's where I went. Okay. All right, so I'm going to quickly go through the skull here. So my collaborator for this Rawr project, Sharif Razak, he did a lot of this fabrication, and then you'll see later in the first version of the nasal passages, Carlo San Marco helped me a lot with that, the fabrication of the nasal passages. So modeling the skull, so we get like CT scan data. So you can see there, it's very complex. So we need to smooth that out so we can print it. And then there's this skull was crushed. There was a crushed half, so we had to mirror it. There's all these things about fossils that make them hard to, as they are, to print and create an instrument with them. So for instance, we were using, for many parts, CNC machines, so we could not have undercuts. So that's something that comes up over, that cannot be printed. So for the nasal passages, some of the big problems of this project is that it was started in 2011 before like 3D printing and fabrication, DIY, like really took off. And so we printed the first, we the nasal passages separately. And they were from a particle printer, 3D-FM. And so these are not resonant, so we had to infiltrate them with epoxy, which means basically we soaked them in glue, and then that made this particulate larynx resonant. And of course, because we had such a small machine, we had to make it in pieces, as you see. And that's Carlo holding the nasal passages. And then, so the outer shell was just a shell for aesthetic reasons. And this is the very first prototype, which did not work out. But then we were later, it turns out that Sharif ran into the creators of ShopBot. So we were able to get one of the largest hobby CNC machines just back in their backyard and get this printed out. And of course, but did not print so well. The details, you can see it just fell apart. So this nose in this first one, I just had to sculpt. There's some like paper mache around there, but it actually kind of made it a little bit more rocky. But the second skull, after the first skull, we were able to get funding, which is amazing. And so we were able to create this in two pieces with the nasal passages hollowed out. So that was printed in foam, and then we covered it in hard urea plastic. And this is quite a bit more resonant than the first one. So you'll see, so this is my collaborator, Sharif. You may notice he's a little startled. Anyway, his reactions are the best in this video, but yeah, I don't think I have any specific sound samples from the previous dinosaur, but this Hadrosaur version was like sonically, it was a leap forward. And we did a sound analysis, so a frequency analysis. I just played a note without the skull, so the larynx without the skull, and then I played the same notes through the skull, and then I did some like frequency analysis, and so you can see that this purple with the skull is that, where the dinosaur best hearing is that it's emphasized. It's much louder here. And then it starts to attenuate here at the dino hearing limit, which is interesting as well. There's like a kind of a peak here in a way, because it starts attenuating here. But anyway, we felt that this did support this did support what the paper's conclusions were, and so we were quite happy. And then secondly, once I had the instrument, I started thinking of it as a composer and as a musician. So I wrote a piece for tuba. So this is How to Speak Dinosaur Courtship. So the conceit of this is just that the Corythosaurus is trying to court a tuba. Middle of the ring. Just a taste there. And then if anyone's interested in the score, or how you score for the Hadrosaur skull instrument, I thought that might be interesting just to get a look at. So now I have just a few minutes to talk about after Rawr. So I have been taking a break from dinosaurs for just a few years and then coming back. So where are the next steps? So I'm really interested in different Corythosauruses, because the more, I guess, familiarity doesn't breed content, it breeds love. I love the Corythosaurus. And so I'd love to hear I have a sub-adult, and what I'm really interested in is an adult, but also we could take a younger one, and then so we could hear as the Corythosaurus ages, or maybe we have an ensemble of a family. And then another thing, because I've been talking with some other paleontologists, so your own Philip Curry suggested that perhaps that Tyrannosaurus rex has nasal passages that might have been used for sound resonation, much like the cassowary, which uses closed mouth vocalization, maybe as well. So this is from Whitmer Labs, which I think I forgot to mention, but I did get the fossils from Larry Whitmer, and he's big into dinosaur CT scans early on. So these are from his lab as well, and this is an Ankylosaurus. So that's an armored dinosaur, if you're not familiar with it. I have like a little skull. It's a really well preserved one. And then its nasal passages are crazy, apparently. And some people think that they are used for sound resonation. So I find those that to be pretty enticing. And then thirdly, you may not know it from the work that I have shown thus far, but I am in fact also a computer scientist. And so I was very enthralled with, as I call it, the poetry of the physical, and I will be. But I will say that the computers and processing offer a lot of possibilities. So I'm intending on building a hybrid mechanical computational larynx. And I'm particularly interested in using machine learning in order to take, say, assumptions and traits about dinosaurs and then also like other animals, and use that to generate or predict vocal mechanisms. So for instance, there is the hypothesis that larger dinosaurs have these closed mouth vocal mechanisms, but also these are, so crocodiles, in fact, how large they are is also is correlated with what kind of formants they have in their voices. So formants are just like acoustic energy in particular frequencies. So there are peaks of acoustic energy or amplitude in particular frequencies. So for instance, they're particularly famous because they allow us to distinguish vowels from each other. So e, ah, they have different formants, but also male, female speaking voices and different musical instruments, and also different crocodiles. And this relationship actually holds for all amniotes, which is most land walking animals, not arthropods. So like amphibians, us, reptiles, dinosaurs. And our size affects our vocal formants. And so I think because I was using information like this is what I mean. And also with assumptions about behavior. Do voices change based on whether they are primarily used for mating, or whether they are also used for mothers taking care of their young, bonding with their young, or finding their young? Things like that, I think, would be really interesting to produce different larynges based on different assumptions via machine learning. And then finally, I'll just go through this quickly. I'm really interested in creating a dinosaur choir, as I have been intimidated by the different life stages of Corythosaurus and dinosaurs. I'm in my other research. I am an Argentine tango dancer, and I have research in Argentine tangos in the idea of participatory music and dance, and how maybe if we have a dinosaur choir that we can interact. Excellent. So if we are empathizing with dinosaurs, what does that mean? So listening to music and making music from other cultures has been associated with decreased prejudice towards that culture. So if we make music together as dinosaurs, I'm interested in what that means. Do we have decreased prejudice in people who are like dinosaurs or just different people? I'm interested in being a dinosaur. So what habits, if we play music over and over again and change our habits, what is it like being at one with an extinct creature? So are we become aware of climate change or ecology, or because it extinct, just the fragility of how we live and who we are as human beings is just a blip. So I'm interested in, how we can open ourselves up and then maybe respond. So those are just some questions, and thank you all. So I have a list of, I did not do this alone. Sharif Razak was my collaborator for Rawr. Garth Payne was my advisor at the time at ASU. Carla was San Marco. Lawrence Whitmer gave me CT scans. And Sally Coyle, Gordon Bickford, Brent Brimhall definitely helped with the iterations. And I got funding from Arizona University, GPSA, and then I'd also like to thank potential collaborators at University of Alberta for discussions that they had with me, including Scott here, Smallwoods, Jawoski, Philip Curry, and Caleb Brown. Oh, Caleb Brown's in Terrell Museum. Okay. Thank you so much.
Thank you so much for that. Wow. And yeah, we're very interested in continuing this discussion. I can't wait to hear the choir, and I must get a copy of that score. I don't know why I haven't asked you that before. It's our students here would just get a real kick out of seeing that. So thanks for that so much. We do have. I would like to open up for questions. I'm looking at the time, and I know some people have to leave at 8. So thanks for those who do have to go. Thanks again for coming tonight. And I think Bo Coleman put this in the chat a few minutes ago, but I just want to put it in again. I hope I got the, oh no, that's not the right one. Sorry, let me try this again. But I'm just trying to put in the chat there we go, we'll try that one. I think that's it. Paste. Oh, for some reason my copy paste on this machine is doing weird things to me today. Anyway, I'll get it in there. I just wanted to make sure that those of you who are aware of the fact that this is part of the symposium are welcome to join us for continuing events. I believe the next event is at 9:30 a.m. tomorrow, a panel with Natalie Lovelace. So please do check out, I'll get this link right and put it in the chat in a second, but please do check out the rest of the symposium if you're able to make it. But for tonight, let's open up for questions. And usually the way we do this, the kind of Zoom etiquette is if you have a question, please go ahead and use the raise your hand feature, which is in the reactions, but the reactions button on the sort of taskbar below. You'll find that a raise hand function there. And when you do that, you can also put your question in the chat. And when it's your turn, Tom can unmute you if you'd like to speak your question. Otherwise, we can read the question from the chat. So, so I will open it up to, it looks like Tom is reminding me there is a question from, I did not see that, Tom. Thanks for putting that, from Lionel, I think. And so perhaps, I don't see that in the chat. Let me just move back up here. I think Tom is going to copy and paste that in. So give us just a moment here. And we do have some nice comments here in the chat. Okay, here we go. Any plans to get your music in the next dinosaur movie? That's a great one. I'll let you answer that. I'm sure there's a lot of ways to think about that.
No current plans, but I did let an email drop of somebody who wanted. I have had one or two people like approach me to like do one of those like animatron things, you know?
Oh,
Like
yeah, animatronics. Yeah.
animatronics, yeah, that. So that perhaps that.
I see a hand from Heather Young Leslie. So please, if you'd like to ask your question, I think Tom can unmute you. Hi,
Thanks,
Heather.
Scott. Hi, Courtney. That was fascinating. I'm an anthropologist, not an archaeologist, but I have worked with archaeologists who were doing things like trying to recreate various sound instruments for various occasions. The question I have for you is, most living creatures make sounds, have a soft palate as well as, and you're using very hard materials. So I'm wondering if you were to do this again, is there a different kind of material that you would like to use because of the idea of the resonance happening with the soft palate as well as the other parts of the vocal chamber?
Yeah, I think that that could be like something to explore in further prototypes for sure. I had a conversation actually with Cesare, he from the art school here, and he was talking about that. I think my immediate concern with it would be logistics.
Yeah. Like what kind of material would that be?
Yeah, I mean, like, again, I don't know, agar. This is not my my strength, but I'm talking to them. I do think that would be extremely fascinating. Yeah, the closer I could get to something biological, the better. It's just it's an iterative process. As I didn't really describe it, it's an iterative design process.
Absolutely, yeah. Well, and what the point that you made about the lung capacity and the ability to actually force things through. I've played conch shells, and it's so hard to do anything other than make one very short, not very resonant note.
Yes. Yeah, I have had people say you should use bellows, but that would maybe for COVID, but
yeah. Anyway, it was wonderful. Thank you very much.
Thank you.
Thanks for that. Let's see. I think we have a question now from Amanda, who has her hand up. So Amanda, if you'd like to ask your question, please do.
Tanishi, hi, I hope you can hear me. I wrote just miigwech. I'm an artist researcher. I'm originally from Treaty 4 in Canada, but I'm living in Norway. So it's 4 a.m. here, so I'm going to hop off really quick. But I just wanted to say I'm so happy I stayed awake because it was so amazing. And I'm a huge fan also of Garth Payne, so it's really cool to see that connection. And NTNU, the university here, has Alex Murray Leslie has been involved with some bioplastics, or no, not plastics, materials for sound and things like this. And we are a part of an all-women's network jam session group that participated at Ars Electronica last year. So that I think might be a great connection for you because Alex makes really amazing things out of instruments out of all sorts of things. So I know I'm rambling. I'm really tired. But amazing work. I just really loved it. So thank you so much, miigwech.
Oh, thank you. Yes. And thank you for that connection. I'm definitely interested in materials.
Thanks, Amanda. And thanks for staying awake for us. Let's see. I actually have a question. I'm just checking to see if there's anyone else. So I remember, Courtney, when your skull was here, I think it was the second version, maybe. Anyway, it was big. And we had it as part of a sound art exhibition called Exhibiting Sound. And I actually volunteered to sit in the gallery for a number of days when it was open, just to kind of be someone on call to help people look at the work. And one of the things I remember noticing is that when people would come in, is there was, as is usually the case, often the case in gallery situations, is there's some tendency, people are tentative, people are a little shy, and so I was really encouraging people to play the skull. And what I noticed is that people, once they got kind of over the initial, kind of fear factor, and started actually playing with the skull, and also got over the initial like, oh, how does this work? And then they kind of tried to figure it out. It became really interesting to see the kinds of people who were willing to kind of linger and experiment with the instrument of what you've created. And so I find it so interesting that you've created something that really, like, there is this tension between like the sort of like gee whiz factor of what it can do versus like the fact that it actually is very expressive as an instrument. And so I just wondered about, as you have thought about this and creating pieces and stuff, one question I guess would be, how much would you rely on improvisation in the performing with this? And also, have you considered creating a series of etudes for learning how to make the various kinds of sounds that are possible for the instrument? That's kind of a funny question, but there you go.
I hadn't directly thought of a series of etudes, but now that you've said it, I definitely am going to do that, because I want to get more. I didn't get to talk about this, but one of the thrusts is that I want to make the stuff open source, and kind of like how laptop orchestras like brought everyone in to doing a laptop orchestra. I'd love if there are like dinosaur choirs just popping up everywhere. And so like maybe there could be like a practice. So yes, etudes would be amazing. As far as like a compositional process, like, yeah, a lot of improvisation is involved. I have that one scored piece, How to Speak Dinosaur Courtship, which will be a cycle at some point, the How to Speak Dinosaur. But I was experimenting, like, what is notated, what is not, what can be notated. I will tell you, I can't say, like, I can mimic my own voice, so I can mimic pitch. So I was really, I don't know if you know who Eva Betova is. She worked with Bang on a Can for a little bit, but she came one time when I was at Dartmouth, and I was so fascinated because she was trying to make the sounds that she made with her voice on the violin and make the sounds the violin made with her voice. And so like I've always used that technique since, and it's been really valuable with the dinosaur because it's an insane feeling to pitch match with the dinosaur.
Well, Marilyn has a question.
Yeah.
Hi, thank you so much for your presentation. Really inspiring how playful it is, but also how kind of scientific and rigorous it is. So thank you so much for sharing. I have a question. What has been the most surprising part of your project?
Oh.
Did you have an idea what dinosaurs would sound like before you started, and was there something that surprised you?
Everything was surprising in the beginning because although I'd done some physical computing thing, again, I'm a musician and a computer scientist. And so like I was making skulls for the first time, and like the whole like 3D stuff, printing stuff was new and new to me. And I had no idea what was out there. So I think that was just the process of making it was continually surprising. It was exhilarating and traumatic. About dinosaurs, I think, I'm not sure what's surprising. I think, okay, I'll say it's really disappointing to me how little we know about the voice. I think I got Larry Whitmer on the phone like once, and I was like, "Are there any larynx remains?" And he's like, "Ha ha ha!" So there was that moment.
Thank you. Well, thank you very much. And can I follow up with another quick question? I'm going to anyway. Do you have any interest in working in virtual reality?
With the dinosaur, maybe it's not something I've thought that much about. I do stuff that's like interactive, like with motion capture, but I kind of like more augmented reality, or like where the response is sound, not visual. But I am interested in having kind of something that you can blow into on your laptop so that you don't even need to print something out to create a dinosaur sound.
I had a feeling she was going to ask that
Thank
question.
you again for your presentation.
You know, isn't Garth Payne doing some VR stuff nowadays too? I'm surprised he didn't ask you that. But I know that's something he's been into too.
Yeah, he has been doing a lot of virtual 3D sound.
Yeah.
With acoustic ecology. So there you go.
Anyone else? We have time for maybe one more if anyone has one. Otherwise, looks like not. So I want to thank everyone again for coming. I hope that you get a chance to see some more of the symposium, and I certainly will be the first to let all of you know when there is more work of Courtney's to hear and or perhaps even see. There's a chance we might have her visiting here next year. We'll see. That would be great to have her back and continue working on things. So I want to just thank the Spark team again, Natalie, Sean, Jillian, Bo. I want to thank Gail Mandrick and Tom Merklinger for helping behind the scenes, as well as Amy Lay, who's also been helping a lot with the organization of the symposium. And thank everyone again here tonight for coming. And hopefully I'll see some of you tomorrow morning at 9:30 for Natalie's panel. And I did find the link and successfully pasted it in this time in the chat. So please take the time to grab that, or just go to spark.ca, or you can also go to the Sound Studies website. Soundstudies.ca also has information about the symposium that will take you right back to this schedule as well. So thanks everyone for coming this evening. I hope you all have an evening filled with dreams of dinosaurs and sounds of dinosaurs. So thanks again. And if you'd like to, as is our tradition, if you'd like to turn on your video and now your sound, Tom can unmute everybody and let's make some Zoom noise. Yay! Woo!
Thank you.
It was really good. Yeah, it was great.
Okay, take care, everybody.
Thanks all.